Orbit components fly the drone in a circle around a point of interest. While I wouldn't recommend flying an orbit around the Statue of Liberty without permission, I thought it would be a fun way to show how an orbit works using Dronelink's export to Google Earth capability. Now, the core settings to an orbit include the altitude, which is obviously the height that the drone will do the orbit, the radius, which is how wide of an orbit the drone will fly, and the direction, whether it's going clockwise or counterclockwise, and then the speed. And that's obviously the speed that the drone will take as it moves around the orbit. There are some fun additional settings available in the advanced section that will be covered in more detail later. These include circumference, which can be defined as any number of degrees, allowing for full circles, semicircles, or even multiple rotations. There is a final altitude setting, which actually allows you to set an initial and a final altitude to create a corkscrew effect. In this case, we've got it going around 10 times because we set the circumference to 3,600 degrees. Next, there is drone heading, which actually lets you define which way the drone faces as it moves around the orbit. In this case, as we're going clockwise, 90 degrees to the path is facing toward the center, 270 degrees would be facing outward. And finally, gimbal orientation. By default, Dronelink has the drone looking at the base, at the center of the orbit. However, by adding in a gimbal orientation and then setting this to something like minus 25 degrees, that's the amount that the gimbal of the camera will tilt downward or upwards. This creates an effect like this, where the drone is actually looking more forward as opposed to looking to base. Usually a better look when it's trying to do an orbit. Again, I will cover how to do all these things in a later video. Now, it is worth mentioning that the drone will normally initially face toward the center of the orbit, so we do recommend flying what we call a verification mission before flying any plan with an orbit on drones with outside-facing collision sensors. But again, I'll cover this later as well. As a follow-up to our earlier videos on the approach on an orbit is actually the start of the orbit, right here. You can move this to a different location and have the orbit fly to this point first before it starts rotating. But overall, the approach of an orbit looks very, very similar to a destination component, as it has a location and an altitude and a speed. Now, the speed defines how fast the orbit flies from the takeoff location to the initial point on the orbit, as well as how fast it goes around the orbit. As described before, the approach defines how the drone will fly from either the takeoff location to the first location on the orbit, or from a previous location. So in this case, let's say we've got this takeoff and we want to go to this location. We can look at the altitude range for this particular orbit, which shows that the drone must reach 225 feet in the air before it starts moving toward the approach. And you can see that in the preview as the drone is not moving away from the initial takeoff location until it has reached its ideal altitude. Now, if we were to add a path, for example, in front of the orbit, the approach would define the behavior as far as it moves from the end of the path to the beginning of the orbit. And again, if we wanted to, we could set an altitude range which would give the drone more flexibility to fly diagonally. With these trees in front, I would recommend not doing that. I would fly vertically before moving over to this location. Now let's look at the big brother to the orbit, the path component.